Hi, and thanks for watching another instructional video for CSCI 1300. In this video, we will cover variable data type declaration between integers and floating point numbers, and what constitutes a number literal. In C++, there are several different types of numbers. You use the integer number type, called int in C++, to denote a whole number without a fractional part. For example, there must be an integer number of cans in any pack of cans. You cannot have a fraction of a can. When a fractional part is required, such as in the number 0.355, we use floating point numbers. The most commonly used type for floating point numbers in C++ is called the double data type. In the table of values here, you can see that whole numbers, integers, can be both positive, negative, or set to 0. Doubles can represent fractions through decimals, so 1/2 can be represented as 0.5, and we can also represent integers using doubles by adding the 0.0 to the end. So we can take an integer, 1, and assign it to a double as 1.0. We can also enter a number in exponential notation, such as 100,000 or 1,000,000, which would be 1e to the 6, which would be the same as inputting a number 1 times 10 to the 6. So any number in exponential notation always will have the data type double. We can also do this with a negative exponent with a double. So if we wanted to do, for instance, 2.96 times 10 to the negative 2, we would get the value of 0.0296. We can just set that into the double directly by using 2.96e negative 2. Note that there are several limitations to initializing doubles or integers. One being that if you have some number that is large and you want to separate it in some way, you cannot use commas. The number will not be allowed. It will throw an error with the compiler. And also, if you have a fractional number, such as 3 1/2, this would have to be entered as 3.5 for the syntax to be correct when assigning it to some variable. Let's jump into some code and see how this works out. In this particular example, we've declared numCans, can volume, and num. NumCans is an integer and contains the value of 50. So it is a whole number. We've declared a double called can volume, which holds the value of 0.355, and another double called num, which we're setting equal to 2.96e to the negative 2. Notice that if I tried to create a number called double num2 and set it equal to 100,000, if I tried to print this to the screen, or I tried to run the program, which I'm going to do now, you're going to notice that I'm going to get an error message because the quotation, the comma, is causing an error in the initialization process with num. But if I was to save this without it, then everything would compile successfully. The same goes if I was to take this num2 and I was to set it to 2 or 3 1/2. If I was to do this, this would cause an error because this would be recognized as some kind of an operation or a division process. So it's expecting something here that it doesn't have. And this is not correct syntax. But if we switch this to 3.5 and we recompile, you can see that we're not getting errors anymore with our code. Let's go ahead and print the numbers that we have assigned values to. And you can see here that numCans is set to 50. Can volume comes out as 0.355. And that our large floating point number with a negative exponent comes out as 0.0296, which is correct. That's all for now. Thanks and happy coding.